Oops. Absolute values. I'm going back into something here that I understand from earlier classes that most of you guys have seen some of this in your algebra classes. We need graph paper. So what I want to do today is revisit to you, guys, I want to get through this here. You need one for notes and one for homework.
How many notes are you taking?
Not much. It won't take long. What I want to look at here is remind you guys of how you started to learn how to graph just about anything. And the very first time you guys started to graph, you always made a table. And when you made your tables, you always picked a couple numbers that were positive, a couple numbers that were negative, and you also chose 0. Ladies, come on. So, I am choosing my domain. -3, -2, -1, 0, 1, 2, 3. And what I'm doing here with the table, which I know that all of you guys know how to do, is you're taking those values for x and substituting in. So in this instance here, I'm figuring out what is the absolute value of -3. Now remember, absolute value is the distance a number is from 0. And can distance ever be negative?
Never.
No.
It's going to make one of those, I think, parabolas or whatever.
No, it's not going to be a parabola. There's no square term here, so these are all going to be linear. These are going to make V's.
Oh, yeah.
All right? So you get 3, 2, 1, 0, 1, 2, 3. Okay? When you take the absolute values of all of those, remember the absolute value of 2 is still 2, the absolute value of 0 is still 0. So when you first learned how to graph, you were generating your domain to get your range. You were getting your input, your x values, to get your output, your y values. You were figuring that out. And now it's just a matter of plotting what you did. And this is how you guys all learn how to graph, no matter where you started from. -3 and 3. And you, with an absolute value graph, you got something like this.
Are they always going to be congruent?
Yes, not congruent, but there's some, what we're calling is called symmetrical. Remember what symmetrical meant?
Like a
Mirrors.
It mirrors each other.
line up the middle, they would, or
Just
folded it.
integrate.
If you folded it, they would line up.
Like that.
So once you make one graph,
It's like a hand
you already
wave.
have the other.
You already have the other. Yep, it just mirrors itself over.
I
So the other introduction that you're going to see here with absolute value, it's going to lead us into our new form of writing out shifted equations. Every equation that we get from here on out has a parent function. A parent function is when your vertex, if you will, or your center, lines up at the origin.
That's lucky.
That's very lucky, because that doesn't always happen. Sometimes it lines up
And another.
in a different spot, like there.
I'm playing at night.
So what happens is that we have to be able to identify how you write out your new coordinates, if you will. So what we have here is something called A, H's, and K's. The generic form of every single absolute value equation is the following. Y equals A times the absolute value of x minus h, bless you, plus k. Now, the important part here,
Do the absolute value take on the shape of parentheses in and
yes they do, great question. The absolute value takes on the role of parentheses in your order of ops, okay? Now, what happens is, your vertex, where the beam meets, will always be at the ordered pair, hk. So your vertex is at h and k. For example, if I say the equation 3 absolute value x minus 2 plus 1. What's my value of a? 3. My value of A is 3. What's my value of H? 2.
Negative.
Why don't we call it AA? Why don't we call it like M or something?
It's because A isn't always going to be slope, if you will.
Because M's are used.
Because when we get to the other types of graphing, when we get to the parabolas, you still have an A value. What's your amplitude?
Okay.
It's the rate at which it's increasing.
All right.
So this is an amplitude, and you'll see that again when we get to trigonometry, when we have A sine something. So that A value takes on a different role. But in this, since we are linear, it's playing the role of slope, and I'm glad you pointed that out right away. Yes, sir.
So H can't be negative then?
No, I'm gonna. What's your value of K here, real quick? Just to finish.
1.
1. Now, what happens here is that we're being extremely literal with our H's and our K's. Our K value is whatever you see here. Plus K, plus 1, it's 1. If it was minus 6, what was K?
6.
Minus 6.
Oh.
All right.
Alright.
When you get to the H part, if it's X minus H, well, the H value is 2. If it was X plus 2, it would be negative 2.
So
All right.
what's this tab?
It is what you need to get in the head, and this will only take 3 or 4 problems. Your H value in this instance is going to be the opposite of what it's showing. It shows minus 2. H is 2. It shows plus 2. H is negative 2. And so on. This is new. This is something new. So your vertex is at H and K. It opens upwards. If A is greater than 0, it opens up. If A is less than 0, it opens down. And that's where you get the idea of your slope, positive slope, negative slope. Don't freak out by seeing a negative value in front of an absolute value sign. That is just saying it's the opposite of the absolute value. So the opposite of the absolute value of X, instead of being upward, would just be downward. That's all it means. The graphs are always V-shaped. It is wider if the absolute value of A is less than 1. A number smaller than 1, like your fractions, 3 over 4, up 3 over 4, or 1/12, up 1 over 12, so it gets real wide. And then it's wide. And then the narrow if it's greater than. And you'll see how this works because it's playing the role of slope. So when we graph these things, you're going to see it only takes 2-3 minutes to graph the first problem, and after that, less and less and less time. These are relatively straightforward, very similar to how we graphed our piecewise functions. We followed a protocol of starting from a certain spot, got a value, change directions, things like that. These guys are even easier than piecewise. So all we're doing today is we're going to graph some. Monday, we'll write equations of them given the graphs. Remember how that was much easier on piecewise? It's the same deal here. You still got to walk your slope, find a vertex, and go from there. So let's look at an example. I'm going to look at the example of y equals negative, well, negative what? What is that number, do you think?
Negative.
Good. Whenever you see a negative symbol without a number, it's implying it's negative 1. So I've got y equals negative absolute value of x plus 2 plus 3. Yes, sir?
Why do you need the absolute value?
Because it's telling me that it's V-shaped. Because if it was negative, if it was just a negative, then I would have negative x plus 1, and I would only have one side of the graph. Absolute value is going to give me 2 values. Okay. So here, the way I start this up is to get the habit of it, A is negative 1. What's H here, guys? Negative 2. And then K is 3. So what I'm doing is I'm starting by listing out my A, my H, and my K. And every time that I do something, I know you guys are writing everything down, not talking to each other, okay? Come on. I do this because every time I have an A, H, and K problem, they all mean something. And being able to identify what they mean, it just makes everything a piece of cake. All right, it makes it real easy. So now I need to know where to start this graph. Well, I got to start the graph at the vertex. The vertex is occurring at -2 and 3, my h and my k. So, -2 and 3. You don't need to worry about open and closed dots on these things. They're all just dots. All right. Will this one go open up or down?
Down.
Why is that? Because A is negative. Very good. So it's got to go down. So now I'm just going to use symmetry, like we were saying a second ago, to plot them. So the A value, when you're looking at absolute value graphs, plays the role of slope. My A value is -1, which tells me I go down one, right one, down one, right one. And then to be symmetrical on the other side, down one, left one. And you're done. If you don't put the arrows on the ends, are you really, really, really wrong? Kind of wrong, just not, I'm not going to mark you wrong, so I'll forget it half the time. And that's all there is to this. Identify your A, H, and K. Plot a vertex. Walk your slope. Mirror it. Not too bad for a Friday? You think so? I know so. Same idea. Y equals 1/2 absolute value x minus 2 minus 3. First few things I'm going to do here again. A, H, K. What's A? 1/2 H, K. Is it 3 or -3? -3. Very good. So that puts your center at 2, 3. Very good. And is this going to open up or down? I want to say up like a cup, but that doesn't look like a cup.
It's like a heart. Oh. Yeah. Oh, no, see, yeah, look at the parentheses.
Is it June? Anyway, so I got 2. Let me move this up a little bit here. I go to 2, -3. And remember, the value of A in absolute value is playing the role of slopes. So what's your slope? Up 1 over 2. And then do the same thing on the other side. There's really not much you can do with these as far as the graphing is concerned. Worst thing you might see out of the problem in the books, they might throw a fractional vertex. Could you guesstimate where it would wind up? You'll be all right. Yes, sir.
I was just curious what a real life application is.
And these are a little more interesting to try to figure out a real life application, to tell you the truth. So I'm going to read a word problem to you. A rainstorm begins as a drizzle. It builds up to heavy rain, then drops back to a drizzle. At which point, those of you guys that are bailing on me, I try to get through it here real fast. On 126, 18 through 25, okay? 126. Wait. I'm going to finish. 18 through 25. There's 8 graphs.
Wait, did you guys like plan it?
All right. So, try this one real quick.
126. 18 to 25? Yeah.
We'll walk through this one together, and then I'll call it a day and let you guys work.
Yeah, we'll be able to finish.
You don't talk.
I hardly tell. I mean, you told him.
See you guys. What? Yeah, it's 126 that. Yeah.
What is it?
Did you write it down?
No.
Somebody have her phone number?
I got it.
Text her.
Okay. Yeah, I feel
It's on the website.
Oh, the question just got so much fun.
Yeah, notice? Notice?
I think I got it.
Woo!
And now it's
Zero?
What's 0?
H.
Good. Do you see an
I
H?
assumed it was 1.
Ah. If you assumed it would be 1, then you'd see a -1.
Whoa.
No, it's okay. Don't laugh at him. That's not nice.
What? No, I was laughing. Did you hear him?
Now, sorry. In this case here, remember, if you don't see an H, it's 0. If you don't see a K, it's 0. You have to see an A value. Because if you have 0 for an A value, then you won't have an absolute value graph. You'll have a horizontal line. Yes, sir.
So it's X1.
Huh?
X is X3.
X?
X is X.
X is just plain old X.
You mean the X value? Yeah, the
So then it's not gonna be 0, 3, right?
What's A?
A is negative 3.
What's H?
0 and H would be X. 0 is 0.
Remember, it's the absolute value of X minus H. Oops. Do you see an H there?
3.
That's the plus K.
Absolute value.
Oh.
There's no H.
No, all right.
There's no H.
All right, yeah.
Does that make more sense?
Yeah.
Okay, 3.
Oh, I forgot to tell you this. How do you distinguish H's and K's? Where do they go? Well, H is your horizontal shift. Left. Your K is your vertical.
Damn.
That's that. What?
Horizontal, left and right. Vertical, up and down.
Oh, you can say X and Y.
What? H and K. There's no X and Y there. It's horizontal.
Domain.
But like for your coordinates, it's still your X and Y coordinates.
So in this case here, your center is at 0, 3, and it's going to open downward. So in the homework, it asks you to identify the center and whether or not it's opening up or down. That's all you have to be able to do when you do that
What's the homework?
prior to graphing.
Page 116.
I'm getting there.
126. 18 through 35.
35 for you.
18 through 35.
What is your slope in this case?
Negative 2.
-2. So you go down 2, right 1, down 2, right 1. Flip it the other way.
Oh, great. That's so similar to mine.
Good. And that's all there is to it.
Is it page 126?
Any questions on this? Yes, sir.
How do you tell if we're pointing up or down?
The value of A. The value of A, if the value of A is negative, it's pointing downward. If the value of A is positive, it's opening upward. Okay? Any others? Exciting. So next week, what we'll do is we'll start with the graphs of those, and we'll write points off of it. So yeah, it's section 2.8, it's page 126, and it's 18 through 25. On one of the problems, I'll put it back up here. I believe you have a y-intercept of 11, or excuse me, a k value of 11. What should you change that to?
Make K 10.
Make it 10.
Let's make it 10. Okay? Does that make sense?
What's on this lesson?
When the bell rings?
15.
Two 10.
210. Sorry,
My bad. What the heck? I want to be able to finish.
Oh, let's go.
If you can't finish 8 problems in 20 minutes,
I don't have my.
8 problems in
Oh, wait, it's right there. Right
That's
there.
3 minutes for
Yeah, can you just keep it up? That'd be awesome. I didn't bring my book.
nope.
Okay.
Let me just say where we're at, and